Breaking news, chemistry is fun.
Why, yes it is, Michael. Now, we're going to head off to our lab where our news correspondents are waiting with a super fun experiment.
In this experiment, hydrochloric acid is added to bleach. This produces chlorine gas, which then reacts with the potassium iodide solution.
Fact 14. The following reaction must take place under the fume hood to vent out the harmful Cl2 gas. Fact 18. As this reaction proceeds, more chlorine gas is evolved into the first vessel. This increases pressure, pushing the gas through to the second vessel. Fact 16. This is a single displacement reaction. Fact 15. Chlorine is higher than iodine on the reactivity series, which is why it displaces the iodine in the potassium iodide solution.
Breaking news, Coke and Mentos has been spotted in the wild. Now let's head on over to our field agent who's recording it happening.
Fact 3. While we do not know the exact cause of the Koch-Mentos reaction, we do know what is not the cause. For instance, the pH does not change, so this is not a simple acid-base reaction as many once thought. Fact 4. We know plenty of factors which make the Koch-Mentos reaction more potent. For instance, rough candy makes the bubbles grow faster because there's more surface area for the bubbles to grow in. Fact 5. We know that Diet Coke has a stronger reaction because the sweetener aspartame creates a lower surface temperature than the sugary water. This is called being a surfactant. Fact 6. The Mentos mints are covered in gum arabic, a surfactant that farther reduces surface tension and allows for more bubble formation. Fact 7. Another reason Mentos have such a potent reaction is because Mentos are dense and sink fast, creating a column of bubbles which seeds more bubbles. Fact 8. Do not cap. This is how you make a bomb, which we're not allowed to do. As the moles of gas inside the container increase, the pressure would increase to the point where the volume could no longer hold the gas, and it would explode.
Sorry to take you away from the lab like that, but such an exciting encounter, we just couldn't miss it, right, Michael?
That's right, Ryan.
So now, let's head back and see how our potassium iodide and chlorine experiments proceed.
Fact 19. As chlorine replaces iodine in the aqueous solution, the iodine gas is dissolved along with the chlorine, creating a dark purple solution.
Here we see our scientist team writing out the ideal gas law. This law shows that as the number of moles of a gas increases, the pressure increases as well. Since many of our reactions today involve both a gas and pressure, this law applies to many of them.
Breaking news! Elephants use toothpaste? Let's go find out more.
Here we see Ryan adding dish soap to a giant graduated cylinder. Next, Michael adds the potassium iodide solution to the beaker. The potassium iodide is simply catalyst and does not appear in the net ionic equation.
Fact 1. The reason you can see steam emerging from the foam is because this reaction is exothermic. This means that heat is released as a product during the reaction. Fact 2. Soap molecules have a hydrophobic and a hydrophilic end. As gases bubble through the soap forms a sandwich layer around a layer of water, with the hydrophilic end pointing to the inside and the hydrophobic layer pointing out. The trapped gas then forms a circle to minimize the surface area.
Our scientist team is now writing out the reaction that causes all of this foam. They proved once again that these reactions are not magic.
We just got the report that more has been happening with the chlorine and potassium iodide reactions, so let's head back and see what's happening.
Fact 17. We continue to add hydrochloric acid as it is the limiting reagent. There's more than enough potassium iodide to react with all the chlorine gas we are adding. Fact 20. As Beer's law states, as the concentration increases, so will absorbance. This is seen as the reaction vessel gets darker and darker purple.
I got it. More breaking news. Baking soda and vinegar makes a foamy volcano. Let's watch.
In order to obtain accurate results, here we are using our accurate temperature probe to check the temperature of the water. It was concluded that the water was indeed hot. Baking soda was then added to the hot water. Dish soap was also added in order to create a foamier product.
Fact 12. The carbon dioxide produced by the baking soda and vinegar reaction is denser than the air around it, so it stays placed in the reaction vessel. Fact 11. Similarly, mixing the reactants adds kinetic energy and speeds the reaction.
After the water, baking soda, and dish soap solution had been carefully mixed, we then added vinegar to create the final product. The reaction was then carried out a second time without the dish soap to produce the product that we would pour on our candle.
Fact 13. When the carbon dioxide from the reaction is poured over the flame, it displaces the oxygen around it, causing the combustion reaction to stop. Fact 9. In the reaction of baking soda and vinegar, sodium bicarbonate in the baking soda reacts with acetic acid in the vinegar to form sodium acetate and carbonic acid, which then decomposes into water and carbon dioxide gas, forming the bubbles you see here.
So, welcome back and goodbye. Thank you for your time here on the Chemistry Report. We hope you learned that chemistry can be fun.
Stay classy, Durham.